Hello everyone, in this video let us solve this question. So we have 2 raised to power x equals x squared, and here we to solve for the value of x. To solve this, solution, so we have 2 raised to power x equals x raised to power 2. So the first thing we're going to do is to introduce natural logarithm to this equation. So we have ln 2 raised to power x equals ln x raised to power 2. Then applying this rule of natural logarithm, that if you have ln a raised to power b, this equals b times ln a. Applying this rule to this equation, we have x times ln 2 equals 2 times ln x. Next, divide this equation by 2x, x we divide x, we have ln 2 over 2 equals 2 we divide 2, ln x over x. Next, we're going to rearrange this equation, right? It becomes ln x over x equals ln 2 over 2. So with this, let us call this equation asterisk, because we can find two solutions from this equation. So we have ln x over x equals ln 2 over 2. And from here, right, if you have e raised to power ln a, this equals to a. So if you also have e raised to power ln x, this equals x. So therefore, in place of x right here, we can introduce e raised to power ln x. Same thing also, in place of 2, we can write 2 as e raised to power ln 2. This will equal 2. So this 2 will be replaced by e raised to power ln 2. So the equation then becomes ln x over x becomes e raised to power ln x equals ln 2 over 2 becomes e raised to power ln 2. So at this junction, making use of this rule of indices, that if you have 1 over a raised to power n, this equals a raised to power minus n. So applying this rule right to this equation, this then becomes ln x times e raised to power minus ln x, and this equals ln 2 times e raised to power minus ln 2. Okay, so with this, we are then going to apply the lambda w function to this equation. The function is given by, if you have an expression a times e raised to power a, once you apply the lambda w function, this equals a. So in this case, we'll notice that a right here is equal to the power of a right here. But in this equation, the power has a negative power. So how do we make this negative power to be right here also, so that they can equal each other? Simply multiply this equation with minus 1. So minus 1 into brackets ln x times e raised to power minus ln x. Okay, and this equals, in brackets, ln 2 times e raised to power minus ln 2 multiplied by minus 1. So minus 1 times ln x minus ln x, then times e raised to power minus ln x. This equals minus 1 times ln 2 minus ln 2, then times e raised to power minus ln 2. Good. So we can then apply the lambda w function to this equation. So w, okay, and then w. So following this function, that w into bracket a times e raised to power a equals a. This then becomes minus ln x equals, this then becomes minus ln 2. So at this junction, minus will cancel minus, we have ln x equals ln 2. So we are then going to introduce base e to this equation. We have e raised to power ln x equals e raised to power ln 2. Okay, so applying this, we will notice that e raised to power ln x equals to x equals e raised to power ln 2 equals 2. So x is equal to 2, okay, for this given equation. But then we say we can get two different solutions for this given right here, for this given asterisk equation. So we have the equation which is ln x over x equals ln 2 over 2. This was the asterisk equation. So let us solve for the second solution of x from this given equation. So right here, we have ln x over x equals, we can write this as 1 times ln 2 over 2. And from here, we can express 1. 1 can be written as 4 over 4, such that this equation then becomes, we have ln x over x equals 1 is 4 over 4 times ln 2 over 2. Okay, so from here, we have it that we have ln x over x equals 2, we divide 4, we have 2, so 2 times ln 2, 2 ln 2 over 4. Then, applying this rule of natural logarithm, that if you have m times ln a, this equals ln a raised to power m. So applying this rule right to this, 2 becomes the power, then we have it as ln x over x equals ln 2 raised to power 2 over 4. Next, we have ln x over x equals ln 2 squared is 4 over 4. Okay, so we are then going to express these denominators as this. So introducing this function, that if you have e raised to power ln a, this equals to a. X right here can be written as e raised to power ln x, because this will give us x. And also 4 can be written as e raised to power ln 4, this will equal 4. So the equation then becomes, we have ln x over x becomes e raised to power ln x equals ln 4 over 4 is e raised to power ln 4. Also, making use of this rule of indices, if you have 1 over a raised to power n, this equals a raised to power minus n. Applying this rule to this equation, we have the equation to become, right here, ln x times e raised to power minus ln x, and this equals ln 4 times e raised to power minus ln 4. Also, at this junction, we're going to make use of the Lambert W function to solve this given equation. The function is given by w times a times e raised to power a. This equals to a. So we'll notice that a right here equals the power a right here. But in this equation, ln x right here is not equal to the power ln x right here. We have a negative power. So to make these two equal each other, simply multiply the equation by minus 1. So we have minus 1 into brackets ln x times e raised to power minus ln x. And this equals minus 1 times ln 4 times e raised to power minus ln 4. Minus 1 times ln x minus ln x times e raised to power minus ln x, okay, equals minus 1 times ln 4 minus ln 4 times e raised to power minus ln 4. So we can then apply the Lambert W function to this. We have this w, okay, equals to w. And if we apply the Lambert W function to this equation, following this rule, we're going to have the value to equal minus ln x. So we have minus ln x equals to, here also becomes minus ln 4. Okay. Also, at this junction, minus to cancel minus, we have ln x equals ln 4. Next, we're going to introduce e as the base to this equation. So e raised to power ln x equals e raised to power ln 4. E raised to power ln x, e will cancel ln, x stands alone, equals e will cancel ln, 4 stands alone, x equals 4. So from this given equation, we have two solutions of x. The first one is right here, that the value of x right here, x equals 2, and the second solution of x equals 4. So x equals 2 and x equals 4. The first and the second solution of x. So with this, I hope you all enjoyed the video. Do well to like this video, subscribe to this channel. Thanks for watching. God bless you.